Hi, today's lesson is on Lewis dots, but this time we're going to look at some specialty cases. What about double, triple bonds? And what about something I personally call mooching bonds? So let's review some of the things we learned previously about drawing Lewis dots for very simple molecules that only had single bonds. So we're going to first put the atom that can make the most bonds in the middle. And that is based on its position on the periodic table. 2, use the correct number of electrons for each atom. You're going to make mistakes if you don't start with the correct number for each. Then, if any of them are single electrons, we got to match them up and pair them up and make bonds. And we always start with the single bonds first before we try something else. And when I'm all done with my Lewis dot, I should have no lone electrons. And the elements in group 4 through 8 should have 8 dots around them. And those in group 1 should only have 2 dots around them, and that's usually a hydrogen. And those in group 2, should have 4 electrons, and those in group 3 should have 6 electrons. So that should be all review. But what if when you're done this doesn't happen? You end up with some lone electrons, or you don't end up with these numbers. You don't have 8 around carbon, or you don't have 2 around hydrogen, or 4 around beryllium, or 6 around boron. What are you supposed to do? Well, I'm glad you asked. That would be our next step. So if we don't get that, if that didn't work out, we're going to try something like a double bond, or maybe a triple bond, or maybe even what we call a mooch bond. Also, another specialty case is what if I have an ion, like an anion, which is negative, or a cation, which is positive. Then I need to add electrons if it's negative, or remove them if they're positive. So let's try some, and I think you'll catch on as we do some together. So these are in your problem book. You can follow along. And for honors, it's page 443. And so that's what we're working on. And I'm doing problem with nitrogen, oxygen, and chlorine. And together, let's draw this molecule. So the first step was figuring out which of these atoms goes in the middle. So nitrogen has 5 electrons. It will bond 3 times. Oxygen has 6 electrons. It will bond 2 times. And chlorine has 7 electrons. It bonds once. So I put the one with the most bonds, which is nitrogen, in the middle. So I put the nitrogen in the middle, and I give it the 5 electrons. I've got to start with the right amount. 1, 2, 3, 4, 5 electrons. And so I'm going to have single bonds. But right from the start, I've noticed that something's going to happen that's odd. I have 3 lone electrons, which means it needs 3 bonds. But I only have 2 more atoms, an oxygen and a chlorine. So even as I'm drawing this, I know something's going to be a little bit different. So let's try the single bonds first, although in my head I realize something else is going to happen. So I'm going to bond this one first. So oxygen bonds here, that's a single bond. And I'm going to use X's this time to represent the oxygen electrons. So 1, 2, 3, 4, 5, 6 electrons. And then chlorine I'm going to put here, but you could have put it down here also. 1, 2, 3, 4, 5, 6, 7 electrons. So I'm done with bonding it, but I check. Chlorine has 2, 4, 6, 8 electrons around it. Nitrogen, however, has 2, 4, 6, only 7. And oxygen has 2, 4, 6, only 7. So this is not correct. So what do? I can do something like a double bond or a triple bond. So you might notice that there's a single electron right here and a single electron right there. They both need partners. So what could I do? I could partner them up. But to partner them up, I should put them between the 2 atoms. So this one comes from nitrogen, and this one comes from the oxygen. So I'm going to erase them. So I got to get my little eraser out. And I'm going to erase these. And instead, I'm going to put them together, match them up. But to match them up, I'm going to put them in the middle. So I'm going to put the dots here and the X here. All right? So let me draw that again, because I've drawn so many things here. So what does that look like? I have now what we call a double bond to nitrogen to oxygen. and this is what it looked like. So there I have it. I have 2, 4, 6, 8 electrons around oxygen, 2, 4, 6, 8 electrons around nitrogen, 2, 4, 6, 8 electrons around oxygen, and I have a correct Lewis dot diagram. So let's try another one. What about carbon dioxide? Carbon wants 4 bonds, so it goes in the middle. 1, 2, 3, 4. And once again, from the start, I realize I need 4 bonds, but I only have 2 oxygen atoms. So I'm probably going to have to end up doubling something up. So I'm going to put an oxygen here and an oxygen here, and then give it 6 electrons. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Don't forget to match them up. After I've paired them up, I still have 4 single electrons. Hopefully you can find them. But what can I do? Well, I can take this electron here and this electron here and pair them up. But when I pair them up, I'm going to put them between the C and the O. So do these in pencil so that you can erase also. So I'm going to erase this one, and I'm going to erase this one. And then I'm going to put it back in the middle. So that's a double bond. I also have a single electron here and a single electron there. So I'm going to erase those and double those up. And so this molecule has 2 double bonds. And if I do the Lewis structure for this one, that's what it looks like. And notice I have 2, 4, 6, 8 around oxygen, because these in the middle count for both oxygen and carbon. Then I have 2, 4, 6, 8 electrons around carbon, and 2, 4, 6, 8 electrons around oxygen. So that is the correct structure for carbon dioxide. All right, let's try one with now a little bit of added difficulty. Notice this has a charge of -1. This is the nitrite ion, NO2-. So what do? I draw it like I did before, but at the end I've got to add an electron because it has a charge of -1. So I put nitrogen in the middle, 1, 2, 3, 4, 5. And then notice I need 3 bonds, but I only have 2 atoms, so I know something is going to be up right from the start. 1, 2, 3, 4, 5, 6. And another oxygen, 1, 2, 3, 4, 5, 6. And then I look, am I done? No, I've got lone electrons, and I also have 7 around oxygen and 7 around nitrogen. So this is not correct. When it's not correct, you have to try something else. What about a double bond or a triple bond? Well, I've got a lone electron here and a lone electron here, so they can pair up. So just like we've done before. I'm going to erase them first, so do this in pencil. And they're going to pair up right in the middle. And I still have a lone electron here, but I don't have a lone electron anywhere else to be its partner. So I can't make another double bond, or I can't triple bond it, but I also have a charge of -1. So I can add an electron. Where should I add it? Right next to this unpaired electron. So now if you look at it, there are 8 electrons around oxygen, 8 around nitrogen, 8 around oxygen on both sides. So there I have it, the NO2-. So hopefully you're staying with me for this one. We got one more odd thing. What about this thing that I call a mooch bond? All right. So let's try this and I'll show you what a mooch bond is. Sulfur and oxygen both want 2 bonds. So how do I know which one goes in the middle? Well, you might look like it's sulfur with 3 oxygens. The sulfur might look like it goes in the middle, which is true. But why is it? We also put the least electronegative ion in the atom in the middle, and that would be sulfur if you remember your electronegativities. So I'm going to put sulfur in the middle and give 1, 2, 3, 4, 5, 6. All right. So now this time I have another odd case. I have 2 lone electrons, but instead of having too few of atoms, I have too many atoms. I have 3 oxygens that I have to add, but only 2 spots. So I could put 1 oxygen here, 1, 2, 3, 4, 5, 6. and one oxygen here. 1, 2, 3, 4, 5, 6. Oops, I added one too many on that. Oh, no, I didn't. That's correct. And I have a 2 minus charge. So I have a missing electron here and a missing electron here, so I could pair them up with my 2 extra electrons. But I still have another oxygen. Where am I going to fit that in? I have no more single electrons. Well, oxygen sometimes mooches. You may have had a friend in life who's a mooch. That's someone who always borrows, and doesn't give. Well, oxygen can sometimes mooch. That means it takes without giving. So sometimes oxygen will bond without giving any of its own electrons. Oxygen has 6 electrons. So it could mooch off these pair here because it's looking for 2 more to get to 8. So I put oxygen here, and notice it's going to mooch off these electrons, which means it's going to share without giving anything of its own. So this is a rare case. Never use a mooch bond unless you have to. And I have 1, 2, 3, 4, 5, 6 electron with oxygen, and it's going to borrow these 2 and not supply any. Notice most of the time if I have a bond, there's 1 electron from each atom. And even when I have a double bond, I have 2 electrons from the oxygen and 2 from the nitrogen. But here in this case, both electrons, and if I put these as X's, you might be able to see it better. Both electrons come from sulfur. Oxygen is supplying none of its own. And that's what we call a mooch bond. In reality, they call it a coordinate covalent bond. So the best way to learn these is to try them yourself. So practice with the pencil until you get the right number of electrons around each atom, and then you know you've done it correctly. If you have questions, bring them to class. Thanks for listening.